So in this video we are going to solve a few numericals based on the Newton's laws of motion and the conservation of the linear momentum. So first one is a man weighing 60 kg runs along a rail with velocity of 18 km per hour and jumps into a car of mass 1 quintal standing on the rails. So calculate the velocity with which the car will start traveling along the rails. So see what are the informations are given. So M1 is given 60 kg, M2 is given 1 quintal, so that means 100 kg. And the man was running, that means U1 was 18 km per hour, which is nothing but 18 into 5 by 18 meter per second, that means 5 meter per second. And the car was at rest, standing on the rail. It is given standing on the rail, so that means it was at rest. So you can write U2 is equal to 0 meter per second. So what happens when the person will jump on the car? The person and car will move together. So you have to find out the velocity of that combination. So let the velocity of the car and the man be v. Right? Let the velocity of the car plus man is equal to v. So now you have to use the formula of conservation of linear momentum. So you can write m1 plus m2 into v after the man will jump on the car is equal to m1 u1 plus m2 u2. That's it. So now you have to find out. You have to solve this. So v you have to find out. So v is equal to m1 u1 plus m2 u2 by m1 plus m2. So is equal to, right, m1 is 60, this one is given 5 plus m2 is 100 into 0 by m1 is 60 plus 100. So if you calculate, I calculated already, so this one is coming 8.875 meter per second. Okay, so this is the answer, that with this velocity the car will travel. Now we go to the next problem, which would require a greater force accelerating a 3 kg mass at 4 meter per second square and 5 kg mass at 2 meter per second square. So very simple sum this one. So for 3 kg mass you can calculate 3 kg mass. What you can find out is that the mass is given 3 kg and acceleration is given 4 meter per second square. So F1 will be equal to M1 A1. So that is nothing but 3 into 4, so is equal to 12 Newton. And for 5 kg mass, F2 is equal to M2A2. So M2 is what? M2 is 5 kg. 5. Acceleration is 2 meter per second square. So 2. So 5 into 2 is 10. So the greater force is required to accelerate 3 kg mass. You can write the greater force accelerate 3 kg mass. Okay, so this is the answer. Now we go to the next problem. Next page, just a minute. So when I read this numerical, an object of mass 20 kg is accelerated uniformly from a velocity of 36 km per hour to 54 km per hour in 25 seconds. Calculate the initial and final momenta of the object. Also find magnitude of the force exerted on the object. So first you have to find out the initial velocity. You have to convert into meter per second. So initial velocity u is equal to 36. So that means 36 into 5 by 18 meter per second. So 2, that means 10 meter per second. Final velocity v will be equal to 54 kilometer per hour. So nothing but 54 into 5 by 18 meter per second, so is equal to 15 meter per second. Okay, so you have to find out the initial momentum. So initial momentum, we can write as pi is equal to mu. M is what? 20 kg. U is given 10. So we'll get 200 kg meter per second. Final momentum. Pf is equal to mb. So it will be 20 again into 15. So we multiply this one 20 to 50, will get 300 kg meter per second. Now force means the change in the time rate of change of momentum is called force. So force exerted on the object, force exerted is equal to F is equal to change in momentum by time. So that means Pf minus Pi by T. So 300 minus 200 by 25 is equal to 4 Newton. Okay, so this is the answer. Now we go to the next problem. A bullet of mass 10 gram is horizontally fired with a velocity of 200 meter per second from a pistol of mass 3 kg. Calculate the recoil velocity of the pistol. So you know that already, you know that the recoil velocity of the pistol may be v2. Okay, so according to conservation of linear momentum, so if you don't understand, you can check the video of the recoil of the cannon which I have made previously. So the formula will be like the recoil velocity, let the recoil velocity be v2. So solution from here, let the recoil be v2. So what will happen? According to conservation of linear momentum, we can write, so m1 v1 plus m2 v2, or you can m2 v2 is equal to 0. This is after firing, this one. before firing will be 0 because pistol and the bullet will be in the rest condition, so completely that is 0. So m1 plus m2 into u, that is 0 because initially the pistol and the bullet was at rest. So v2 will be how much? So v2 will be your minus m1 v1 by m2, so which is nothing but minus 0.01 into 200, and then how much is 3 kg? 3 kg means okay, so already converted this one. No, 10 gram means 0.01 kg, so it's given 3 kg, so this is 3 kg. So you can write here m1 is equal to 10 gram is equal to 0.01 kg. So first you have to convert this one. So now this kg would get cancelled, and then you will only get the velocity here. So you get minus 0.67 meter per second. That is the answer. Okay, so today is up to this. So next class we'll continue with some other numericals. So thank you very much.